Hello again and welcome. Today we're going to be looking at a brand new Brymen meter. This is the BM786. This meter is not available to the general public yet. As a matter of fact, this cover is not the final version. I believe that this is a cover from the BM789. If this shows up in the camera, we can see here the temperature. There's some black tape. But they've told me that the circuit board that's in this particular meter is the final released version. So is the firmware. The back cover would all be the same. The only difference between this and what's going to be available to the public is going to be the lettering on the face of the meter. So I haven't been testing a lot of meters lately. So why this one in particular? Well, Dave up on EEV blog had made an announcement about a year ago that he was interested in adding a new meter to his portfolio. Sometime later, he finally reveals that he's looking at a Brymen. So I'd reached out to Brymen to ask if I could get one of these meters to do a review on. And of course they were very accommodating and sent me this. We could have waited until the generic cover was available, but I really didn't see a point. The only time the tape would become an issue in my testing is when I expose the meter to various chemicals. So what I'll do is I'll just avoid that taped area when I run that test. I haven't done anything with this meter yet. So let's go ahead and we'll do a basic functional test of it. Just a few general comments about the meter. This is a 60,000 count meter. We can see this is rated for 1000 volts Cat 3, 600 volt Cat 4. We can see the meter is obviously true RMS, but it also has AC plus DC. You can also see it has a variable frequency drive mode. Here's our AC plus DC modes for millivolts as well as volts. You can also see it has a conductance mode. It has a single temperature input. Now its big brother, the 789, actually has two temperature inputs, just like the BM869. We can see it also has functions for microamps, milliamps, and amps. So just for a quick check, we'll be using our little test box. We'll just start with the AC volt mode, and this should be 2.5 volts. Looks fine. Let's just see if it picks up the frequency. Should be 60 Hertz. That's fine. In this particular mode of the box, the signal is AC coupled. Let's just try it in DC coupled. Again, this should be 60 Hertz. That's nice because the meter is able to actually read the frequency without the zero cross. Let's just try it at 30 Hertz. This is 15. And this is 120. So you can see on the bar graph, as I push level, see how that changes. I believe that's changing the threshold level for this, so let's just see, as I crank this up, can it pick it up? No, it can't. Let's try going back to the original. Yeah, so it has, I believe, a different threshold that it's using. Second bar, third, oh, right there it drops out. And let's go back to AC volts. So again, this should be 2.5. This is DC coupled. Let's have a look at the DC voltage. That should be 2.5. That's fine. Let's just try it in AC plus DC mode. Again, for AC plus DC, we're basically taking the DC component squared plus the AC component squared, and then taking the square root of that. So if you use 2.5 for both, it should work out to roughly 3.535. And you can see 3.521. Of course, the voltage on this reads a little low. That's not the fault of the meter, that's actually this box. So looks like AC plus DC works fine. This should be somewhere around 70 volts. Just for a quick comparison, this is my BM869S. This is the meter that I had just recently installed the latest firmware, if you watch that last video I made. So it has the extended backlight timer. Alright, let's go ahead and re-enable this. You can see both meters are fairly close. Again, this is a complex waveform. You can see it's running up at 3.15 kilohertz. Let's just see if the little Brymen can pick that up. Yeah, 3.18685. It's nice, it's got one added digit. Let's just go to DC. Again, this should be roughly 60 volts DC. Oh, and here's our problem. Again, for AC, yeah, that's right. And again, for DC, this is not 4.4 volts. Let's try changing the range on it. There you go. So 58 volts, 58, 58. It's probably fairly close. So these three meters are all in parallel right now. We can see the Fluke 189 as well as the Brymen BM869S both agree, and we can see the 786 is definitely reading low. I think that it could be because of the high frequency noise, and if we were to slow this down a little bit, let me just grab a capacitor. There you go. So this is a 100 picofarads. Let's just put this right across the meter's leads. We'll just stuff them in the, probably doesn't have to make real good contact. And there you go. So again, it's in auto range right now. As a matter of fact, let's just turn it off. Turn it back on. I expect it's going to work. Yeah, so it looks like something maybe could be improved with the auto range. My guess again is it's just the high frequency off of this test box. As a matter of fact, I've got some other meters out here. My guess is the added loading of having these meters on here is going to make all the meters read the same. Alright, so all these now are in parallel. Let's go ahead and turn it on, and we can see they're all reading roughly the same voltage. Let's go ahead and we'll remove our capacitor. And there you go, so 93.9 now. So again, I suspect it's just having a problem with the high frequency off of our test box. Alright, so I've changed all the meters over to their AC plus DC modes. Let's just try it now. And it looks like they're all basically displaying 102 volts. X-Tech's a little high at 104. And let's go ahead and change them back to their AC modes. And again, you can see they're all reading roughly 39 and some change. Looks like the X-Tech's reading a little low, but all well within reason. So my guess now, again, is if we remove our test leads, because I'm guessing the added capacitance of the meters is dragging this power supply down a little bit, and as you can see, sure enough, the voltage goes up. So yeah, I don't know if they could improve on that or not. Let's go ahead and we'll just continue on with our testing. Let's just go to our millivolt range. Again, this should be roughly 20 millivolts. Good enough. Let's try our frequency mode here. So again, this should be roughly 60 hertz. That looks fine. Here's 30 hertz. Yeah, I'm sure that works fine. Alright, so the meter is in conductance mode right now. Let's just try it with our 1 giga ohm resistor. Again, this should read roughly 1 nanosiemen. Looks like it's settled. See if our leads have any effect on that at all. Doesn't look like it, so 103. Let's try it with 100 meg. This should read 10. Again, basically we're looking at the reciprocal. So yeah, fairly close, 9.99. And this will be a 40 mega ohm resistor. Should read 25. Fairly close. Let's just go to resistance mode. Obviously that meter is going to take quite a while to settle, and let's just go ahead and time it. So it auto ranges fairly quickly. Let's go back to our 40 meg. Yeah, so about 15 seconds to settle. Alright, so this is going to be a 10 mega ohm, 1% part. Looks about right. This is a 1 meg, 1%. Looks good. As we're going to lower values, it's definitely speeding up. This is a 100K 0.1%. This is a 10K 1%. This is a 1K 0.1%. This is a 100 ohm 0.01%. This is a 50 ohm, 0.01%. This is a 1 ohm, 1%. Let's try shorting out our leads. This will be a 0.5, 1% part. You can see it's definitely got a negative offset to it. I'd actually like if that were reading a little hot. If I weren't using these short leads, you know, something added, maybe another 1/10 of an ohm, we could go ahead and rel that out. It's probably designed to work with the leads that come with the meter. Again, if you're trying to measure low resistance values like this, you're going to typically use a 4-wire system anyway. This is the continuity mode. It's kind of nice. You can see they light the backlight. All right, let's try capacitance. This will be a 150 picofarads. See, it's a little slow, but it's dead on. This will be a 1 nanofarad. Looks good. This will be a 0.1 microfarad. Yep, that looks fine. And this will be a 1 microfarad. Looks real good. 10 microfarads. Looks fine. And 100 microfarads. Again, let's see if it drifts down. Looks like it's settled about 103.5. Pretty good. I'd like something a little faster, but not a problem. Alright, let's try temperature. This should be roughly 500 degrees Celsius. Pretty good. Let's try it down at lower temps again. This should be roughly 24 degrees Celsius. Looks real good. This should be about 1040. Looks fine. Here's with our lead shorted. This will be a single diode, 2 diodes. Let's just try it with our white. Oh, it can pick that up. 2.5 volts. It's about right. It's pretty decent. I know the BM869S cannot read the voltage off of that white LED. Let's just try it in microamps real quick. And this should be 100 microamps. Pretty much spot on. This will be 10 microamps. And this is 1 microamp. So it looks real good. So it looks like the meter is functional. There's a couple of things I should probably show you with this meter. This meter has some abilities, like for example to turn the auto power off. Again, like all the other Brymans, you just hold the select key, turn it on. You can see auto power off. We want to disable the beeper. We select the range. So now it's enabled. Now for example, when I hit the range key, so it beeps on every button selection. A lot of people I'm sure would find that quite annoying. Oh yeah, same thing with crest mode. Let's just try turning on the rec mode. So it's going to beep on every update. Again, so we'd select the range, power it up, should turn the beeper back off. Yep, so it's disable beeper. And now let's go to record. And again, it's nice and quiet. So like most of the Brymans, this meter records those functions. So let's just go ahead and we'll turn it back on. Again, the beeper's been disabled. And let's hit the record. And we can see there's no beeper. And let's go ahead and turn it back on. Enable beep. And let's hit the record. Now let's turn it off. And we'll turn it back on. And let's hit the record. So it sticks. All of these meters shown here are all true RMS. They all support AC plus DC. They're all 40,000 counts or higher. This meter on the left, this is made by Summit. It's the TPI 194-2. This is a 50,000 count meter. The cost on this is about $250. To the right of the BM786 we have the Brymen BM869S. Again, this meter cost me about $230. It also has a resolution of 50,000 counts, but it also includes this 500,000 count mode. It's limited what you can use that for. To the right of that we have the Fluke 189. This meter's been obsolete for many years. It's no longer available for purchase, so we won't consider a price on it. This meter is also 50,000 counts. To the right we have the Unity UT181A. This meter costs $300 and is 60,000 counts. To the right of that I have my X-Tech EX540. This meter is made by SEM. It goes by the model number DT9939. I have the SEM version of it that I paid like $120 for. This is the lowest resolution meter of the ones being shown at 40,000 counts. Currently all the meters are attached in parallel and they're connected to my Fluke reference standards. We're currently supplying 1 millivolt. We can see basically all the meters are reading the same value. So all these meters are now in their DC volt mode. You can see we're applying 1 volt DC, and again this is off of the Fluke reference. I'm sure that reference is being loaded having this many meters attached to it, but you can see they're all roughly reading the same value. And this is with 10 volts being applied to all 6 meters. Again, we can see they're all quite accurate. Let's have a look at the backlight of this meter. You can see this 194 is pretty dim. It looks okay. Alright, so I brought the meters outside. Kind of a dreary day. You can see it's fall. See if I can give you a better idea what the contrast looks like between these meters. Again, this is our BM786. Try to keep it out of the glare. See, the contrast looks pretty decent with it. Let's try our backlight out here. Again, this is the lowest setting, and that's the highest setting. And again, this is with the TPI. It only has the one setting. And this is our little SEM meter. Again, it only has the one setting. It's tough to beat this display on the 181. So off to my left here, you can see I have one of our high voltage power supplies out. Both these meters are attached in parallel. We'll be performing some AC voltage tests with this, so this power supply I know can't run too many meters in parallel, so we'll just run with these two for now. So here we are at 600 volts. Looks like both meters reading spot on. We'll enable the 500,000 count mode on the BM869. It's pretty impressive. They're almost within a count of one another. Let's go ahead and we'll take it up higher. Pretty good. That's 1020 volts or so. Alright, I have our high voltage power supply strapped for AC mode. And you can see we are now putting out about 541 volts AC, roughly 55 volts DC, and we can see the DC content on this Fluke as well. We switch this over to AC. You can see roughly 542 volts. Now we have the BM786 set for DC volts right now, and you can see it's basically reading 0. This is currently at 60 Hertz, so let's just go to frequency. You can see it picks that up just fine. Let's see what it reads for the AC voltage. It's about right, 534 versus 541. A little off, but not a problem. Let's try it in AC plus DC mode. Let's see what it reads. So 546, and there you have it. So all 3 meters are in their AC plus DC mode, and they're all reading roughly the same value. Tell you what, let's switch this back to DC. We'll leave this in AC plus DC so you can have the AC content up here, the AC plus DC, and our DC value over here. And let's try changing the voltage a little bit. So you can see I'm changing the bias voltage. You can see what kind of an effect that has. Both meters reading roughly the same value. Let's try it back over on AC volts. Again, fairly close. What I don't like with this, again, is it's still reading 0 DC volts. And I'm pretty sure that this is a problem with the auto range. Let's just try it. So we'll manually auto range. There you go. You can see the meter's basically dead on with a fluke. Let's try changing the bias a little further. Let's go negative with it. Again, no problem here. And again, this is 60 Hertz, so other than it being a square wave, I'm surprised it's having any issues with this. Again, let's go back to AC voltage. Again, fairly close, 541 versus 533. You can see we are offset now by about 530 volts. Let's try adjusting it down a little further. See if it picks it up. Doesn't seem to. Let's cut our AC voltage in half and see if it picks it up. Even with half the AC line voltage, so we're at 283 right now and 15 volts offset. You can see the meter still is unable to pick this up. And it doesn't matter if it's a positive or negative voltage. Yeah, it's a little disappointing. I don't know if they can fix this in the firmware. I'll get in touch with Brymen and I'll let them know what I'm seeing, and we'll see what they say about it. This is our transient generator on the right. This has a transformer inside of it, so it takes the AC line voltage, so that's basically 110 to 120 volts here in the US, and it steps it up to 2 times, so 220 volts or so, and then it runs it through a full wave rectifier, and that's available at the output here. So what I'm going to do is I'm just going to turn that on real quick, and you can see the 786 is having no trouble reading that DC voltage. So 234, it's dead on. Let's switch it over to AC. Should be about 121 volts, 122, yep. And that's basically what I would expect. Let's go to AC plus DC. And we'll do that with the fluke as well. And you can see the 2 meters are reading spot on with each other. So I have had meters that couldn't even read this full wave rectified AC voltage. It doesn't appear to be a problem with this particular Brymen, but I'm still surprised it's having trouble with that square wave. I really think that this is the same problem that we had before, where essentially I'm driving the meter with a square wave, and for whatever reason the auto range isn't able to handle that. The problem that I see that you could have with this is if, for say, that you're working with a VFD drive or something and you're trying to look at the DC content of the waveform, it's possible that this meter isn't able to actually read a waveform like that. So I think what I'd like to do is set up where we run this thing through a suite of waveforms, and let's just see which ones it has a problem with. So it looks like we're coming up on 20 minutes right now. I think that this is probably as good a place to stop as any. I've gone ahead and contacted Brymen by email. I think what I'd like to do is just give them an opportunity to kind of take this all in and maybe figure out if there's a correction that they can make for this auto range problem that we're seeing. I think for the next video, there's a few things I want to do. One of them would be, again, to try running some of those complex waveforms through all these meters. And then I'm planning to display those probably on the oscilloscope at the same time. I'd also like to do some basic comparisons between these meters. I think I'd like to keep these videos at about a half an hour each. I'm not too concerned about people's attention span, but it does allow me to give you a little faster feedback as far as what I'm seeing with the meter while I'm going through the tests. So I hope you've enjoyed the series so far. There's a lot more to come, so stay safe and stay tuned. Later.